Hello everyone, this is Logan with Pytes Marketing Team. Welcome to the very first episode of Pytes Broadcast. Today we're diving into high voltage energy storage system in CAI projects, how they work, why they're adopted, and most importantly, what installers need to know to avoid costly mistakes on the job site. Joining me today is Logan, the product manager at Pytes, who work really closely with engineering team and installers on the job site. So hi Logan, glad to have you here. Before we jump right in, could you please briefly introduce yourself a little bit, like your working experience, background, or anything you would like the audience to know?
Sure, of course. Thanks so much, Lemon, for having me here at Pytes headquarters in Shanghai. I'm really excited to be here, and I'm product manager with Pytes USA. I've got about 10 years in the renewable energy industry nowadays. I started working for a national level solar equipment distributor in Arizona, where I gained a lot of experience with a number of different products, different applications, everything from small, weather monitoring systems with a single solar panel and a lead acid battery, all the way up to large scale megawatt hour systems with massive PV arrays and lithium batteries. So yeah, definitely have seen a lot in the industry over the last 10 years and a lot of changes, especially. But again, really excited to be here today and talk a little bit more about our high voltage battery solutions.
Wow, great. Okay, so Logan, many installers we speak to say things like high voltage systems are more efficient, so higher voltage is always better. So is that true, or is there something more to the story?
Yeah, good question. Not necessarily. I don't think it's true in all cases. So high voltage in general, high voltage battery systems, I should say, is sort of a relatively new thing we're seeing in the industry lately. I know in my previous role working for a distributor, I was doing system design and sales, all kinds of technical support. We really didn't use high voltage batteries all that much. But since joining Pytes over the last couple of years, I've learned a great deal about high voltage batteries and commercial energy storage. So that definitely has some advantages, right? One of the biggest ones for me is when you look at a high voltage battery system, your voltages from the different inputs in your system are running at a more similar potential. So what I mean by that is your voltage from your solar panels, the voltage of your AC output, the voltage of the batteries are all a little closer together compared to a low voltage system where you've got your batteries down at 48 volts and then everything else could be 200, 500, 600 volts. So keeping everything closer together helps us reduce conversion losses, and it generally just makes the system operate more efficiently overall. Another benefit is because we have this higher potential, you can now typically use smaller cable size between your inverter and your batteries. You can locate the two components further away without really significant voltage drop or having to use big heavy cables. When we talk about the inverter side as well on the C&I space, a lot of these inverters are natively with the three-phase AC output. 208 volts or 480 volts are the two most common voltages we see in the field in the Americas anyways. So a lot of these commercial inverters, like companies like Sol-Ark, Solis, EG4, for example, these inverters, one unit on its own is able to produce this three-phase output that's needed for a lot of these applications. Whereas in the low voltage space, you typically are looking at stacking multiple smaller inverters, we'll say, to achieve that same desired goal. And then one more thing on the high voltage side that I think is really advantageous, and this is a little more specific to how we've designed our high voltage solution, is we try to include really everything an installer is going to need for a complete installation with the high voltage batteries. So it makes your bill of materials incredibly simple and really helps save time during the design process too.
It sounds like high voltage system does have a lot of benefits. It's not for everybody to use. Just for the specific scenarios, right? Right.
So there's a lot of positives and advantages going with the high voltage system, but we could talk quite a bit about the advantages for low voltage as well. I think the biggest advantage still right now, even after all the advantage in the commercial space, is low voltage is definitely still the most widely accepted solution. It's still the most common. Many installers out there are very familiar with low voltage batteries. Many AHJs are familiar with that as well. So especially when we look at DIY installers, right, or homeowners who want to install their own system by themselves, the low voltage side or the low voltage product offerings are typically a little easier to use. We could say maybe a little safer. Generally, there's a lot more accessories and supporting components that are available for low voltage battery systems as opposed to the high voltage side. And another thing to think about is if you're ever retrofitting an existing system, right? Maybe somebody has a really old off-grid solar system that has aging lead acid batteries and they're looking to replace those with lithium. Well, you can just replace the batteries and typically leave all of the other components the same because the voltage of the batteries matches the voltage that the equipment wants. And then another important advantage that low voltage still has, I think, is it's a lot more cost effective for smaller systems, right? What I mean by that is technically you could have just one single battery and your inverter, and that becomes a complete and fully functioning system. Most people might need more than just one battery for their needs, but because that one battery on its own is already meeting the inverter's input voltage on the battery side, that might be all you need for really small scale projects.
Thank you, Logan, for your very detailed explanation. So there's another question for those who are new to this. Could you please give a quick overview of what defines a high voltage system on a CAI project?
Of course. Yeah, I'll take this as an opportunity, I think, to go back to basics, if you will, and sort of think back to the days of lead acid batteries when we were usually dealing with both series and parallel connections within the same battery bank. When we talk about high voltage systems, it's really just a different method of connection. The battery modules themselves or the core architecture is the same, right? Our high voltage batteries, for the most part, like these ones behind me, these are our HV48100. Each one of these is a 5 kilowatt hour battery that's 51.2 volts nominal. That's the exact same specs that we have for our low voltage V5 and E-Box series as well. So again, the difference is for high voltage, we're connecting in series. We're going positive to negative to raise the voltage on the DC bus, whereas with our low voltage systems, we're connecting our batteries in parallel. So parallel, again, right, is positives to positives, negative to negatives. And when we do parallel connections, we're maintaining that voltage the same, but we're increasing our amp hour capacity or our charge and discharge capacity.
So the difference is how you connect the batteries, one in parallel, one in series, right?
That's basically the difference. Yeah, high voltage systems, we have batteries connected in series. Low voltage systems, the batteries are connected in parallel. So it's important to note, though, when we talk about this high voltage concept, I don't know, sometimes we can make it sound better than low voltage or somehow it has secret hidden energy that we're unlocking, but that's really not the case, right? If you look at a system with 8, high voltage batteries and a system with 8 low voltage V5 batteries, the amount of energy you have in both of those systems is the same, right? 8 batteries times 5 kilowatt hours, it's still 40 kilowatt hours total for your bank. Again, all that's changing is either the voltage or the amp hours, and we're doing that by using a different connection method. For the sake of today's video, when we talk about C&I storage, commercial and industrial storage, we're really just referring to systems that are using high voltage batteries. The boundaries between residential and C&I applications are not by any means set in stone, right? So you can have a residential project that uses high voltage batteries. You can also have a commercial project that uses low voltage batteries. All about what's best for the application. But again, we're sort of talking about the high voltage products today in a commercial and industrial sense.
We're seeing more commercial and industrial projects adopting high voltage architectures. So Logan, what's driving this shift? And what should installers understand about its benefits?
Yeah, I think at least in the United States right now, we really are witnessing a shift from residential installations to commercial installations. A lot of installers and EPCs, for example, are pivoting into the commercial space because mostly due to the expiration of the residential solar tax credit that ended in 2025. So it's a little more difficult now for homeowners and end users to, finance a residential project. And for that reason, like I said, a lot of the installers are taking on more and more commercial jobs. So when we talk about these commercial projects that are becoming more and more frequent and more common, we can take a closer look at some of the technical details and try to explain why high voltage batteries just make more sense for these types of applications. I think one of those reasons is on the inverter side. When we look at some of the inverters that we use with our high voltage battery systems in the US and the rest of the Americas, like Sol-Ark and Solis, those inverters already produce a 3-phase AC output, usually either 208 volts or 480 volts, depending on the grid voltage or what the application needs, right? We can do that with just one single inverter rather than stacking three smaller inverters to get that same 3-phase output. So it really does simplify the design and overall makes things a lot more efficient. Talk about the inverters and we compare a system that has one large inverter, let's say, as opposed to 3 smaller inverters. You're usually saving a lot in terms of not just the inverter cost, but also your supporting accessories, right? It's less cable, less conduit, less components overall to get the same end result. And touching on the batteries really quick too, because we have such a higher voltage, what that's doing, it's reducing the amperage or the amount of current that's traveling between the batteries in the inverter, for example. So what that means is we're spending less money on cables. The amount of copper that's needed in our installations for bus bars and things like that is greatly reduced. And I think you could make an argument too, it's a little bit of a lower risk as well, having the current or the amperage at a much safer and more manageable level. And because we have that reduced amperage in our system, it makes these commercial projects much, much easier to scale up, into the megawatt hour range without, needing a crazy amount of copper material or spending a ton of money on copper anyways.
Yeah, this is really critical.
Yeah, for sure.
From your experience, what are some of the most common mistakes the installers may make on the job site when they're deploying high voltage systems?
I think there's a few, right? Maybe the most common, the one to be the most aware of is failing to recharge the batteries within 6 months of receipt. So we do recommend recharging the batteries within 6 months of the manufacturing date. So kind of just a heads up, if there's an installer planning on storing the batteries long-term at the site before the installation occurs, make sure you're checking that manufacturing date, make sure you're making plans for recharging, whether that's through a DC power supply or even just temporarily connecting the batteries to the inverter. But it's important we do that because after the batteries sit for long enough, like any battery, right, they begin to self-discharge. So the state of charge of the battery starts decreasing and decreasing and decreasing. If left unresolved for long enough, you can start to see the batteries, the high voltage batteries anyways, become or obtain, I'll say, different states of charge. And so then when we go to connect them all in series, they have a lot more difficulty balancing and equalizing that state of charge amongst themselves compared to a low voltage system. So I would say, yeah, the long-term storage or lack of recharge is definitely one of the biggest things.
Okay, well, anything else for the common mistakes?
Yeah, another thing I've noticed in the field lately on the past couple projects, and this has become sort of a pro tip for me, if you will, is just simple labeling the power and communication cables between your batteries and your inverter. It really sounds basic, but it's worth the extra couple minutes to get that done. Can really save you some serious headaches in the future. Right, a lot of these inverters we work with, they have 2 battery inputs per inverter, and often you'll have 2 groups of batteries or 2 battery cabinets connected to the same inverter. Each battery group is connected to a different input, and so sometimes if you have battery 1 connected to input 2 and battery 2 is connected to input 1, that can cause some very abnormal behavior and charging and discharging. So yeah, adding some simple labels on either ends of your cables, your batteries and your comm cables, especially for large installations, especially for installations where everything is in conduit, it's something that can really help you long term. I'd say my last common mistake, or something that I would highly, highly recommend, is read the manuals, study the documentation, right? Make sure you're going to the site prepared. Like I said, these high voltage batteries are, for us, a relatively new product. And for many installers, it's relatively new, especially those installers that just recently switched over from residential to commercial, right? There's important startup and shutdown procedures that we have to follow, other important installation guidance in all of our documentation. So just make sure you take a look at that before you get to the site and, prepare as best you can.
Oh, that's great. Thank you, Logan. And when those mistakes happen, what kind of consequences are we talking about? Like performance loss, a safety risk, or financial impact?
Good question. Yeah, all of the above, I could say, right? So sometimes these mistakes can obviously lead to improper operation. Imbalance issues can mean unused capacity in the system. Maybe we mix up our BMS communication cables between input 1 and 2. Now the batteries aren't charging and discharging properly. Any number of these things would typically require the installer to go back to the site or to send a crew back to the site, right? So now we're talking more truck rolls. Now we're talking more time and resources spent to get that system up and running, where some of these issues we could have easily avoided in the first place.
It sounds really costly for the installers.
Yeah,
so better
absolutely.
Learn before you start.
Exactly.
Let's talk about solutions. We've been talking a lot about the mistakes and the things you have to look after. So if an installer is preparing for high voltage project, what are the top 3 things that they have to pay attention to or double check before installation?
Yeah, great question. For me, number 1 is make sure you bring our console cable accessory and a Windows laptop with you to the site. I would even suggest leaving those items at the site in case issues arise in the future. That is hands down our most useful and powerful tool when it comes to troubleshooting. The console cable accessory is just a simple RJ45 to USB cable. You can get that from us. We can send you a link to get it at a third party. But that allows us to do things like firmware updates as part of commissioning. It lets us double check the status of the batteries, their state of charge. And, sometimes when we have issues in the field, an installer might not have that cable. Maybe they don't have the computer. We sometimes reach a standstill where we can't really do too much on the after sales side until we have those 2 components. So that would be my top recommendation by far is make sure you've got the console cable, make sure you've got your laptop in your truck, in your tool bag. And if needed, you can leave those items at the site indefinitely in case you need them again, or in case somebody else is going to be picking up the maintenance after the original installation. The second thing that installers should double check before they perform their installation are things like your wire runs, the height of the cabinet, the total weight of the cabinet. Right, as I said earlier, most of our high voltage solutions, our indoor solutions anyways, come included with all the cables, connectors, pretty much everything you need to put the batteries together in the cabinet like you see behind me, and also to connect the cabinet to your inverter. So what I'm getting at is we have pre-made cables that are a certain length. Make sure those are going to work for your install. If not, contact us. We can help you work out custom cables or get you the connectors. Check your clearances on your cabinet. Make sure the cabinet height is not an issue for the space you're installing it in. Make sure wherever you're putting the cabinet can support the weight of the cabinet with all the batteries inside. We really want to try to avoid doing any kind of custom modifications in the field unless it's absolutely necessary. So the more instances you can use, the more often you can use our solutions as they were designed to be used, the easier it will be for you and just make your install process a lot simpler. And the last thing, or the third thing, is double checking that manufacturing date on the batteries. And again, plan for recharging or plan your installation accordingly. Like I mentioned before, we want to try to avoid that long-term storage that can potentially lead to balancing issues at the end of the day.
Okay, thank you, Logan, for a very thorough advice. And I also want to know, do you have any practical tips to save time, reduce troubleshooting, or avoid unnecessary headaches during and after installation?
I definitely recommend to reach out to our team far in advance before your installation, or if you're needing on-site troubleshooting support. Let us know as soon as you can, just so we can make sure we've got the right people on the other end of the phone to help the installers while they're on site. Keep in mind, a lot of these commercial projects, right, are using 50, 60, sometimes up to 100 or more batteries. And when we talk about troubleshooting a site that big, and especially doing updates and things like that, it just takes a lot more time compared to, a residential system that might only have 6 to 8 batteries. So, make sure you're scheduling that time on your end as the installer, but also just give us a heads up as early as you can, again, to make sure we've got the right people available to support you through that process.
Yeah, that's important. And Pytes team always stand by like 24/7. As long as you have a problem, just reach us out.
Of course, yeah. Round the clock support you get from us. I mean, if it's not our US or LATAM team that's helping you, you're talking directly with our engineering team in China. So yeah, we really try to be there for the installers as much as we can.
Okay, anything else?
Something else that can really save us time and headache down the road is setting up remote monitoring as part of the commissioning process. So a lot of the inverters we work with have Wi-Fi monitoring built in. Our battery models as well have Wi-Fi monitoring just the same. And this is a free service. You just need to provide Wi-Fi to the equipment, and we can connect to it and take a look at it remotely. That lets you as the installer keep an eye on it after you put it in. That lets the homeowner or the system owner check things out. Most importantly, it lets our technical team look at the batteries, review everything, make sure it's all operating as we expect. I know sometimes maybe time's running tight on an installation. Maybe we ran into an issue or two that we had to address and we don't have time, or we ran out of daylight to set up the remote monitoring. I would say do what you can to push that extra little bit and try to get that monitoring piece set up when you commission the system. So again, we can keep an eye on it and make sure everything is running properly. Last thing for me, I know I've mentioned this or hinted at it before in the conversation, but just prepare as best you can, right? Study our resources, read the manuals, go through the integration guides. I talked about the console cable in the computer. You can make sure the connection works with your laptop before you go to site. You can download any documents or firmware you might need from us. So yeah, ultimately, the more you can prepare, the smoother the project installation will go.
High voltage systems are great tools, but only if when they're installed and designed properly. Most issues aren't the tech itself. Sometimes they come from early decisions. So please consult with experts before you start planning. It can really save your time and energy. Thanks everyone for watching the very first episode of Pytes Broadcast, and a big thank you for Logan for joining us and sharing your expertise and practical tips on high voltage systems.
Of course, yes. Thanks very much for having me. Very excited to be here, and I look forward to future episodes.
Great! If you found this video helpful, don't forget to like, subscribe, and leave the comments below. They're really important to us, and your feedback helps us to shape the future episodes. And I'll see you in the next episode. Bye!